started, Linda.
Okay, thank you. So, good afternoon, everyone. A warm welcome to all of you to today's data dialogue session. And it's wonderful to see such an enthusiastic gathering coming together to explore evolving frontiers of digital transformation. So, as we know today, data today is not just powering innovations, it's shaping governance, infrastructure, sustainability goals, and so on. At the core of this transformation lies the geospatial data. This enables further in making smarter decisions, targeted intervention, and more connected governance ecosystem. Today, we have the privilege of hearing from a pioneering voice in India's geospatial and digital governance space, Shri Vishnu Chandra, former Deputy Director General at National Informatics Center. With over 3 decades of service, he has played a significant role in integrating geospatial technologies into national digital platforms. He has led numerous critical projects across ministries, including housing and urban affairs, environment, power, and disaster management. He also has shaped key policy reforms around GIS and remote sensing in India. As an alumnus of IIT Roorkee, he continues to contribute as an advisor to the Ministry of Panchayat Raj and serves as an independent director at SASHR. So, the topic of today's data dialogue, geospatial data and services for digital transformation, is especially timely and relevant. Shri Vishnu Chandra will walk us through emerging technologies, evolving governance, workflows, and some real world case studies implemented, all anchored around how spatial intelligence is becoming indispensable in this digital era. Let us now welcome Shri Vishnu Chandra ji to take us through his insights.
Thanks a lot, Linda.
Thank you.
I extend my thanks to Center for Data for Public Good and Center of Society and Policy IIST for giving me an opportunity to speak on geospatial data and services for digital transformation. See, the agenda which I am going to cover is listed here. See, I will going to speak about GeoVision of governance, Geo by Design. What does it mean? Most of the traditional digital public infrastructure platforms are non-spatial. They start from non-spatial side. Generally, traditionally, what most of the, because IT systems started getting developed much earlier than evolution or changes before mainstreaming of GIS and geospatial things. So that's why Geo by Design, that concept is quite recent. Then subsequently, I will cover digital transformation overview. We were working on a spatial data infrastructure from last 15 years or so. Then spatial data infrastructure versus digital transformation, what kind of paradigm shift is coming because of the growth of ICT technology, cloud, quantum computing, and so on. And then followed by certain use cases, particularly two use where geospatial data is being used. Then what kind of future action, policies, principles and policies, and capacity building. So these are the things which are going to cover in my webinar today. So GeoVision of governance. As you all know, geography or geospatial is a core foundation for decision support system, and is a platform by default where man-made as well as natural events or phenomena interact real time in parallel simultaneously. That's why it is known as science of where. Though computing as a science is sequential process, but with advancement of digital technologies like supercomputing, parallel processing, including various data capture platforms like IoT, sensors, drone, mobile, lidar, you can call them as science of how and when. as well as analytics platform like big data, AI, ML, science of what. We are in process of building end-to-end ecosystem, our value chain, deploying near real-time geovision as core foundation of decision-making and governance process. So spatial planning in convergence with computational technology is leading to what you call digital transformation in governance system with considerable ESG benefits. ESG geospatial is a subject in itself now. Spatial thinking leading to process by Geo by design. So this is just a representation what I mean. And for any project, any work, from planning, design to implementation, the entire workflow has to be Geo by design because location itself is playing a greater role. If you see the breadth of geospatial applications, no sector is untouched. Energy, agriculture, infrastructure, urban, rural, transportation, environment, health, public safety, and so on. And most of the government schemes and programs and DPI relates to the sectors mentioned here. For example, PM Surya Ghar Yojana deals with solarization of rooftop solarization in urban as well as rural area. Pradhan Mantri Awas Yojana, Swachh Bharat Mission, Ayushman Bharat, Soil Health Card, Land Records, Smart City, Amrut. All these are the PDS, EPDS. So all these are the big platforms where geospatial has a role, and most of these platforms last at least you can say 5-6 years we are retrofitting geospatial. So they are not geospatial by design, but now there are certain use cases which we are going taking a geospatial view as a front end, and then we are integrating workflow processes and other things. For example, even soil health card. Soil health card does not view the soil conditions starting from maps. Again, it is a data collection system, and then we try to make the location of soil samples captured through mobile app on base map. So it is other way around. So this is what we need. Subsequently, we need quality and trusted, affordable geospatial data and services which are in high demand to support digital transformation goals for any public and private organizations. And for future demand like housing, retail, investment, net zero emissions, schooling, rail infrastructure, and so on. So we have to move in towards a process, what you call Geo by design for the digital public infrastructure and digital transformation. This is what you can say various verticals. This is just a representation. There are many more things in terms of geostatistics technology, from GNSS positioning, analytics, earth observation, 3D scanning. So from data capture to workflow management to analytics, integration of earth observation and 3D scanning. So all this is covered end-to-end geospatial technology. These are certain concepts. You must always, because you are all, I'm speaking to geospatial professionals. So all these are the modern GIS conceptual models. Digital transformation is a process of using digital technology to fundamentally change how a business operates and delivers value to customers. It involves integrating digital technologies into all aspects of the business, including products, processes, and strategies, and customer experience. So these are the stages of components of digital transformation: conversion of data, digitalization, making it a part of workflow and process, and then generating business value, creating values. In fact, if you see the history of computerization and IT intervention in India, since early 90s, the focus was more on data conversion.
Is it only for me or is Is Sir's frame stuck?
Even for me. So I should check with him.
Sir, can you hear us? I think there's some issue on his end. Probably he'll rejoin. Mr. Chandra is joining in a minute or two.
Yeah, I'm available.
Yes, sir.
And my slides are visible.
No, sir. We can only see you, but not your slides.
Again, I have to share them.
Yeah.
Is it visible?
No, sir. We can see your computer screen, but not the presentation. Yeah. Now we can see the presentation.
So I left on this slide or previous slide where I was.
So from ninth slide could be the ninth slide.
This one?
The one
This one
before.
I have covered?
The one before. You were talking about this.
I was talking about this.
Yeah. No, this is done. The next one.
I was talking about this.
The component slide.
Yeah. I was saying, okay, see, these are the three components of digital transformation. And these are also the stages of evolution of what you call digital systems. When India is introducing the e-governance system in early 90s or late 80s, focus was on conversion of data, particularly textual data. And maps was available as a DGN scanned file, design file format. Then we have moved for digitalization, where client server architecture, Windows, partly internet has also emerging in mid 90s. ADR, analysis ready data, and create business value for real digital transformation and delivery of services through platforms. So at each of these stages, there is a technology change, there is a policy change. Early 90s, policy-wise, it was too restrictive. Then we have 95 policy came, which allowed 10 agencies to digitize maps. Then 2005 policy came. Now 2022 policy came. Accordingly, technology has also advanced from desktop to client server to internet and so on. So this is how these components can also be related with the evolution of the digital system in India or worldwide. Objective of digital transformation is these fourfold. When we say improved customer experience, computing infrastructure, cloud platform, definitely it is getting further scaled up with edge computing and so many other things. Then collaboration using video conferencing, online task management, and even social media, and accessibility of content, for customer facing activities, for delivery of services, and what you call to make informed evidence-based decision making. This is the building blocks, operational backbone with integrated system and processes, with high level of operational efficiency and quality of transaction and master data, shared customer insight, organizational knowledge about the customers, and then digital technologies to deliver on demand. Then digital platform for delivery, as a repository of business technology and data component, accountability framework defining clear-cut ownership and coordination among growing set of digital offerings on components, then external development platforms of various stakeholders. In fact, UGI as a platform for digital transformation has to address all these block and components. If you talk about geospatial data and services, its role in digital transformation, one is these, you can say, 6 items which I have listed. One is, of course, location intelligence, like market trends, assets, doorstep citizen services, data-driven decision making, the geospatial and business data integration for informed decisions for resource allocation and business strategy planning, operational efficiency, like geospatial analytics for supply chain management, route planning, improved facility monitoring, risk management to identify and mitigate risks due to natural disasters, infrastructure failures, supply chain disruptions. Innovation is basically to generate more insight by integrating geospatial data with AI for future business strategy and planning. Of course, monitoring sustainable development goals and government applications, e-governance, urban planning, disaster response, and so on. So traditionally what has happened, whether in a research domain or application domain, the mapping applications, earth observation applications has grown as a separate application. IT systems with textual data has grown as a separate system. The marriage of two systems, integrating survey, the mapping data and earth observation data with governance workflow as a part of IT system, that is a recent phenomenon. And it is happening because many of the technologies and tools on IT side, which can capture location, either through mobile and through other IoT devices, it's also started happening. So attribute information, real-time attribution, vis-a-vis geospatial data is now reality. So this marriage is now happening, and that is going ultimately attribution, ground truthing can come from traditional IT system with respect to a particular area and location, which is defined by maps or earth observation data. These are the technology factors which are affecting, or technology which are affecting for digital transformation. Of course, big data in terms of its volume, velocity, and variety, Internet of Things, artificial intelligence, deep learning, augmented reality, BIM and indoor mapping, sector-specific engineering software platforms for hydrology, for agriculture, for water resources, and so on. Cloud, edge, and quantum computing. So, and then some kind of integration at top of geospatial technologies like GeoICT, GeoICT as a what you call as a concept for geospatial knowledge infrastructure, Geo-IoT, Geo-AI, Geo-BIM, and digital twins. So this is now going to affect digital transformation. This is another slide which I have sourced from TerraWatch, which is talking about, Earth observation stack, where data as a service, built and launch satellite to collect different kind of data from space with direct licensing. Then platform as a service, data agnostic, then insight as a service. So all this as a Earth observation stack should be made available. This is you can say work in progress. This is what the requirement. If these services are available to governance applications, then a lot of change in detection analytics and so many things can happen. And this is another view of Earth observation value chain, from say what you call data as a service, data acquisition, platform as a service for dissemination, analytics as a service, as analytics, insight as a converting satellite data to actionable insights, as if for a domain specific and vertical specific. Analytics can be vertical agnostic also. Then application software as a service for a vertical domain specific requirements like agriculture, water resources, and so on. Geo-IoT as a tool for monitoring, for quality data, with remote configuration capability, for application like water information, pollution information, and so on. So Geo-IoT to capture real-time data and integrate with workflows is one of the requirement, and it is also started happening now. Now this slide is very important when we talk about futuristic thing. This is sourced from McKinsey and Company. There are 10 major technology trends which is happening. One is, of course, distributed infrastructure for data flows into the cloud and enabling strategies to make it more market friendly. So distributed infrastructure, making data flow into the cloud, including part of edge computing and so many things. Second is applied AI, generative AI, agentized AI, all these are getting reality. Third is next generation computing. So which is a fast development cycle and which will disrupt value chain, because once you move to quantum computing, the speed scale is going to be huge. Future of programming. So with neural networks and AI and agentized AI, now you will have agents available for a particular vertical. So future of programming, software 2.0 based on neural networks and machine learning, and no programs are built in future. Then trust architecture. Trust architecture, entire your public key infrastructure, your cyber security, where is going to change with quantum computing. And trust architecture is also needing the quality, precision, accurate geospatial data. Then future of connectivity with super fast connectivity, and which can support seamless personalized communication. That is sixth. Next level of process automation and virtualization, robotics, IoT, digital twins, 3D and 4D printing. All these things are going to happen. And clean tech with green technology generation to meet growing needs. Then biorevolution, from food to health. Bioscience combined with computing and machine learning and artificial intelligence. Then next generation material. Next generation material is nanomaterials and all, even your storage, battery, all those going to use next generation material. So this together as a package is basically 10 technology trend for future digital transformation, And geospatial, along with AI, IoT, distributed computing, next generation computing are what we are calling geospatial knowledge infrastructure. All these 10 trends are going to affect design of geospatial knowledge infrastructure. So next section is spatial data infrastructure versus digital transformation. What paradigm shift is happening? See, as India as a country has played a major role in setting up of large national level SDIs, geo platforms. We have Bhuvan, Bharat Maps, Bhunidhi, PM Gati Shakti, state SDIs also like Karnataka GIS, and platform has grown and lot of national flagship programs are integrated with these geospatial portals and platforms. So mostly platform institutions by government department ministries, visual map analytics, charting, crowdsourcing, asset mapping, inventory, support for planning and development, natural source map, open source, open standard compliant services, scalability, high availability, and traditional. And we are looking for an environment where fair practices can be findable, accessible, interoperable, reusable systems can be evolved. Paradigm shift from SDI to cloud native GKI. So with cloud native, distributed, scalable, resilient, manageable, observable, automated, high available, agile, and with fair practices desired. Geo platform be designed with cloud native architecture, applications to be optimally leveraged for the benefits of the cloud computing delivery model with containers, service meshes, microservices, immutable infrastructure, and declarative APIs. So these techniques, in fact, I am presenting this. Ultimately, if you have to scale up of, say, UGI, you have to design your enterprise geospatial knowledge infrastructure with the help of these technology components. We have earlier we used to have there are 3 stages. This is also a evolution. Cloud enabled, where we used to create dedicated physical servers or co-location servers. We used to create VMs with known predefined point storage and BSFS OS storages. Then we have moved to cloud ready with database API toolkits application, containers, but still predefined point, full on storage, CPU limited scalable, database partitioning, load balancing, duplication of duplicate or handling of duplication. So all these things, now we have moved our GIS platform to cloud ready environment. Now technology is moving for cloud native, where high scalability with serverless model, allowing developers to build an application without having any managed server. Earlier stages were lot of managed servers and resources has to be put on how to manage in data center the servers. Now it is all automated, run application without having any managed servers, serverless model services, scale storage, even you can scale storage CPU for required time period, massive scalability as per the application demand, and multi-elastic cloud. So this is what the evolution in terms of cloud technology, which has already happened. These are the basic design of cloud native system promising technology listed here. And many of these technologies, UGI system must be already using, like raster data format like cloud of GeoTIFF COG, vector data format with a special indexing schema like flat GeoBuff, image convert to COG, and so many things. So all these technology set are being promising technology for cloud native systems. This is a display of service-oriented architecture schematic, where these are the services example, backend database, and through gateway API, things are delivered through web portal and through mobile app. This is a depiction of geospatial tech stack, where GIS development stack, application development stack, and a stack for mobile development and data science and AI is depicted along with what you call API soup. So this also gives the direction what kind of human resource capacities are needed to decide geospatial tech stack for a particular platform and application. Because you need skills people, say for example, AngularJS or Node.js implementation, say on ArcGIS, or Node.js or AngularJS implementation on say GeoServer, and so on. So combination, I have tried to put various options in this single slide. Use cases. I am presenting here two major schemes or use cases where geospatial has been used very extensively. One is, of course, the Swamitva scheme and geospatial planning platform called Gram Manchitra, in which I am also involved as an advisor of Ministry of Panchayati Raj. Earlier, since inception of this activity in 2019, when I was DDG and IC, that I was part of what you call planning and initiating this scheme. Second use case application, which I am going to speak about, is which is a very high-end what you call application platform, which has even business to government, government to business, government to citizen, citizen to citizen, all components embedded into it, known as Parivesh, which is green platform developed for Ministry of Environment and Forest. Since both these platforms uses as a foundation GIS, the Geospatial Data and Service, Bharat Maps. So this is just a overview of slide of Bharat Maps. What does it contain? So it is a multi-layer, multi-scale, multi-resolution platform where maps up to 10,000 K and satellite imagery from say 56 meter to say 2.5 and 1 meter, and certain base map services, foundation services like terrain map service using 20-meter contour, NIC street map up to 10,000 scale, NIC satellite base map, along with a common base map service from OpenCV, OSM, or base map services created out of Swamitva data, all are put in this platform. And there is also map service portal to exchange with government applications for WMS and WFS services out of Bharat Maps data. Gram Manchitra is a geospatial data platform, online thematic map preparation, reverse geocoding, using administrative, using location, all these services. And these are the point of interest data from various ministries and departments. This is just a depiction of how an ICGIS cloud is functioning with Bharat Map as a base information, as a foundation data at top of cloud and security infrastructure, integrating various sectoral information around common foundation data and services. So these are all independent use cases for various ministries and departments, and cloud-based geospatial platform services are a common services. No data is getting duplicated or replicated for any of the application, and and each of the application consume to and fro API-based services. This is what some overview of Swamitva, progress swamitva.nic.in, where complete monitoring, progress tracking, display of key performance indicator, statistical analysis, drill down till village level, beneficiary level details of property cards, all these things are being put together. Data management under Swamitva scheme, drone images, large scale maps, property parcel database, property card information, that is input data, raw image in tagged image file format TIFF, then projection standardization, band standardization, compressing the data as ECW format, and then on-prem cloud data storage and an IC data center is being built with the support of Ministry of Panchayati Raj for further service creation and integration of this data into various applications. This is again a snapshot. Grammanchitra.gov.in, whatever the Swamitva data is getting integrated in this platform. Integration with Grammanchitra. There are 29 sector attribute data is flowing and getting integrated as a part of a special database for further analysis. Some of the parameters are listed here. It is in addition to the drone image or orthorectified image or parcel data of Abadi area. So this is in addition to that for further geoanalytics, a conglomeration of a special database for analysis purpose has been built. So if you see that, so this is a unified platform with 29 sector data for Gram Panchayat planning, linking relevant data along the geographic data for specific objectives, spatial analysis tools, real-time tracking of progress, work undertaken in different schemes, and Gram Panchayat profile with details of Sarpanch and functioners, and also provides the statistics in terms of with respect to administrative navigation, in terms of status of drone flying and property card generation and distribution, different base map services from say an IC street map, terrain map services, and other drone-based image services. This is what profile tool with real-time weather advisory delivered at Panchayat level. This advisory is coming from through API from IMD. So every day and every say few hours, this information is shared and integrated on this platform. This is Gram Panchayat profile with census for Gram Panchayat development plan status. This is NREGA works. So NREGA data API is coming from Ministry of Rural Development with geotag photograph, and it is being integrated and shown to Panchayat functionary for integrated planning. This is a very important tool, which is now we are converging with PM Surya Ghar Yojana for rooftop solarization using Swamitva drone image. So this all calculation for different size of the solar panels are being done by identifying which are the rooftop with RCC structure are available and what are the calculations in terms of numbers and cost. Property tax visualization. So tool for property tax calculation in Panchayat with using what you call drone image of Abadi area. Beauty is this drone imaging has been done for property guard, but now we are out of it for different applications. Street light tool. So different kind of street light, their size, their distance, these tools are being built within this platform. Road construction tool. Automatically cost can also be calculated, distance can also be calculated, and all that. Village travel feasibility with various kind of vehicles, because in a village if some vehicle comes of which size, what kind of width of the road, so one can navigate accordingly. Now 3D mapping. So with this we have built to navigate inside the village what you call the complete 3D mapping for including rotation of tools so that better planning can be done. More tools we are trying to develop using this kind of data, using drone image created by Survey of India and provided to MOPR. Ultimately, this will facilitate. We are in a stage of POC to create some kind of Abadi area digital twin where real-time monitoring benefits, policy regulation can happen. This is work in progress. So this is the future benefits. Recent to build this tool to enhance and create value of data which was primarily collected for we have done certain development using AI/ML and also to support sustainable development goals as per UNGGIM. Say, for example, rooftop. I talked about rooftop solarization application. Feature extraction of rooftop using AI/ML and around 25,000 villages that we have already completed. We have also created vendor panel to automate this process so that for identifying rooftop of different category, RCC, tin, kacha, and all that. And then for the further development of poverty index and all that, this is what this also helps. Rooftop also helps in building some kind of electric infrastructure and so many things. Building footprints, feature extraction for property tax calculation, support in healthcare accessibility, further help in land use analysis. So these exercise in automated manner we are building slowly. Water bodies for help in planning of water scare and water rich GPs, help in planning for water recharge, help in planning for check dams, promote water demand calculation and take proactive steps for water sufficient GPs. Road extraction, plan for better public service delivery and solar powered street lights and GPs with road, particularly these requirement becomes very important in those GPs which are peri-urban. Peri-urban means they are close to some big city, they are close to some national highway where big national highways are coming. So when land acquisition and all those things happen, these kind of analysis becomes very important. Second part is what you call Parivesh single window green clearance platform, and it is known as proactive and responsive facilitation by interactive and virtuous environment single window hub. So this has grown single source of truth, effective through process and data synchronization, transparent informed decision making, minimum government, maximum governance. This is the evolution. What I'm trying to say, there is the evolution in terms of digital services and digital platform. In pre-2014, online application submission and clearing process. Then it has started into some kind of individual BAP. See, there are 4 major clearances: environment clearance, forest clearance, wildlife clearance, and coastal regulation zone clearance. So individual web page launched for application submission of EC and FC, and offline clearing process. Online application आता था, offline clearing होती थी. 2018 में they have launched single window portal, application submission and processing without GIS. There was no GIS in it, except a scanned copy of maps, including Survey of India topo sheets, were uploaded. So there was no GIS, and locations as a part of area of interest KML was submitted by proponents. Proponents could be any public sector industry like NTPC, NHPC, and so on. It could be a private sector company like Reliance or Adani's. It could be any, say, road, NHAI. So proponents are even to set up a hospitality industry, set up a resort in certain areas. So all these are the proponents. They used to submit their KML file, an area of interest topo sheet, scanned copy. That was the stage of 2018. Now, 2019 onward, further services, these services were rolled out to states, UTs. Then 2021 major study has been done in terms of impact of system created in 2018, what are the gaps and what should the future approach? And 2022 complete unified portal with Geo By Design as a core has been launched for monitoring of this purpose. So GIS portal has around 122 spatial layers. And 20 layers include foundation data services from Bharat Maps. So some of these categories of the layers are listed here. It is complete DSS with tool-based analysis, query-based analysis, sensitivity analysis, like Forest Survey of India, decision-based analysis. Now, when I am talking about decision, here major reform has been done to codify decision rules from office memorandum issued for various kind of clearances since 1990. Say the rules are like a particular activity can be allowed up to what distance from, say, protected area boundary or eco-sensitive boundary. These rules, through AI/ML, we have created a document database where rationalization of rule in terms of repetitivity, language has been standardized. So these rules as a backend database has been integrated with GIS-based workflow. Like if you see the entire end-to-end workflow of this digital public infrastructure platform, first proponent-facing interface is know your approval and registration of all proponents, eKYC, Aadhaar based. So this is the two input side activity for any proponent. Know your approval means a proponent will come on the portal before filing his application. He will upload his KML file. Authenticity of the KML file with respect to Survey of India reference will get checked on platform itself, and automatically he will get on map the guidance, what kind of clearance is required for his area of interest, and and why comes from based on decision rule database. Then if he decide his KML file, the information and guidance coming is correct, he can move to common application form where the input at KYA level, if he desire, can get automatically filled in common application form in terms of the state, district, village, LGD code, with respect to topo sheet numbers falling in the area of interest, and so on. So then subsequently he can fill the information as per his project area requirement. After filling of the common, and during common application form, for example, for forest clearance, he has to give alternate compensatory forestation site. Those KML also get verified as a part of the process, whether it is in terms of its consistency, quality, accuracy, and in terms of any violation. Once common application is formed, the moves for what you call clearance management, the DSS, and access of this clearance management module and DSS is to 39 expert committees. And those expert committees can see in this area of interest the proponent information, already clears legacy projects in the same area, and they can apply various GIS tools in terms of using the decision rule table as a part of workflow management. And once the clearance is allowed, then automatically clearance order is generated. Then things moves, system generate approvals, and then it moves to compliance monitoring. And for compliance monitoring, again, there is a backend database of catalog condition, because the approval order gives these clearances have been granted with respect to such following condition to be complied. So catalog condition database, around 250,000 conditions have been rationalized from various OEMs to roughly 25-30,000 catalog conditions. And for decision rule database and condition database, there is a provision in the back end with the system administrator to update, because as per the new orders and when it has been updated and all that complete metadata of that. So this is what end-to-end system. So this is again a depiction and flowchart from proponent, workflow management, and this is all Geo by design. Know your approval, submit proposal, the workflow moves to rule engine, decision support system, document management. All this part is a total of workflow part. This is a snapshot. Say know your approval. If you can simply upload the KML and give certain parameters in terms of project capacity, sub-activities. So there are more than 50 activities kind of defined, and these parameters is defined. And then he gets this kind of table. You need this kind of with maps. What kind of clearances are clearance required for updated area of interest? KML verification happens online. Earlier, KML used to be quite accurate. Now, with reference framework is available on GIS platform, automated KML verification is done. There is no need to upload scanned copy of topo sheets. All information is available on GIS platform. Then DSS, tools for analyzing project location such as proximity to important layers in terms of eco-sensitive zone and other things. GIS-based DSS based on objective parameters for identification of inviolate forest area based on protected area, tiger reserves, and all those layers. So this is what broadly I have shown few slides, but this is a huge application. And in fact, today for any area of interest, it is for environmentalist, ecologist, analytics people, they can identify, find out the load in terms of developmental projects going in a particular area. And they can do further environmental sustainability analysis in terms of ecosystem viability and future sustainability. And then again, it can move, say, efficiency of clearance process is one aspect. Other aspect is its impact, environmental impact on ground, and then a feedback system for future policy reforms. Now that part is suggested to ministry, because if ministry decide to share this data with academician and research people, they can bring out further policy reforms, which activity should be allowed where or not, and they can make some kind of a dynamic system which can take care of efficiency of clearances process, as well as sustainability requirements in terms of ecosystem and environmental system sustainability. Now, what you call geospatial digital transformation future actions. As we know, our new geospatial policy, we are talking about digital twins. So this is again a value chain from, say, basic model of real world, then some kind of capacity of feedback and control through sensors and IoTs. Third is predictive modeling to provide analytics and insight. Then some kind of integration of real-time communication for various sources of data and surrounding environment. And then fifth is artificial intelligence, and this is some kind of a closed loop. That is what a future application of digital twin. And digital twin could be from automobile to environment to agriculture to urban cities. For, say, dams, for any subject, you can have a digital twin which can simulate digital digitally the physical real world and provide some kind of predictive modeling to assess how the system will grow and what it will happen after, say, 5 years, 10 years, and 25 years. So you can have that kind of environment. And as a part of this, various technologies, as I said in previous slides, are being used. This is one report. In fact, I am just trying to give you about what you call food and land use systems, some kind of systems approach. And a report by Food and Land Use System, Food and Land Use India, has been commissioned. It is lead author is Dr. P.S. Roy, distinguished scientist, ISRO, and fortunately, I am also one of the co-author of that. So this is, I'm trying to say is, on right hand, on this side, there are databases and information content, and other side is what you call DSS. And then in the middle, I am representing what you call geospatial knowledge infrastructure for food and land use platform. So this is this convergence to today, as of now, like crop yield models. Now, crop yield models using satellite data, those applications are independent applications. Attribute side, shopping system, market outreach, they are independent verticals working as a digital platform. Now, if we have to have a food and land use system as a systems of systems, then we have to have some kind of a Geo by design. You have to have digital platform with geospatial embedded into it. And in terms of workflow, the databases in previous slide, which I am listed here, soil, climate, and ground data of geospatial representation, earth observation, weather, all this data has to be further classified at strategic level, tactical level, technical level, in terms of database design. So resource management areas, for example, could be agriculture, soil, climate. Resource management activities could be, say, crop stress, land degradation, and so on. And resource management actions will be in terms of DSS and specific solutions. And it will be multi-scale, multi-resolution. So the parameterization of database, what should be the parameter, at what scale, at what accuracy should be at a strategic level. This RMAs, RMACs, and RMF functions. This matrix should be defined to all levels and need to be mapped with the sources of data and data services. So such kind of today, and that this process needs lot of rules, lot of standardization, because independent verticals are there. How to make earth observation and satellite and map-based system to talk with the attribute system, with overall goal to have a effective, efficient food and land use system in the country. So this is what is a future action which is required. It is not, food and land use system cannot be limited to Ministry of Agriculture. There has to be involvement of PDS systems, fertilizer systems, supply chain agencies, private entities, and so on and so forth. So this is what ultimately, if platform like UGI has to succeed, they have to address these kind of requirements in coming time and scale their cloud and enterprise geospatial knowledge infrastructure to that level. Principles and policies. Core geospatial principles are well known. We need open and fair exchange of geospatial data and services, and good effort in terms of UGI is already on. generating value for economic development, digital transformation, geospatial as a core service for DPI, data for development to support SDG, UNGGIM, IGF, future emerging technology and digital ecosystem like digital twin, national security, policy framework adopting to emerging technologies, collaboration, public-private partnership, and Atmanirbhar Bharat. These are core principles. We already know this is the policies which are recent time has been in past has come. These are the highlights of the policy. Foundation phase, which are already in, is establishing and enabling geospatial policy and legal framework based on liberalized democratization and value addition, boost availability and accessibility of geospatial data across sectors, and build foundational geospatial infrastructure for, say, land records, urban planning, and infrastructure. The strengthening phase is active high resolution base map, digital elevation model. These are the, by 2000 strengthening phase, we need a high resolution 30 centimeter, 50 centimeter satellite base map with regular update so that change detection can be done, and various further AI ML based application can be further developed. And by 2035, national digital twin for urban cities, major cities. So these are the timelines. We need integrated geospatial system. Today, we have a space policy, geospatial policy, drone policy, and various data policies. But somewhere, multi-layer, multi-scale, multi-spatial resolution, heterogeneous sources, variable data generation process and platforms. There has to be a single window system as a part of policies, because there is a requirement at data captured side. Data may be captured using satellite, aerial platform, drone, but fusing the data from multiple platform, from multiple format to create integrated base map is a requirement. Authentication process for heterogeneous data from multiple source and platforms. So that is the requirement. So then building data product and services out of it, and then delivering services for various geospatial stakeholders and customers. Capacity building, it's a very key requirement. And as we know, end-to-end geospatial ecosystem is huge, from data capture to data standardization, data preparation, workflow management, analytics, and delivery of services. So entire range. And if we have a skilled people at various levels, it can impact. There is a study, it can impact 2 to 3% country's GDP. There is a challenge, shortage of quality manpower, especially in middle and top skills pyramid, high attrition, skill gap at entry level, course curriculum needs revision, faculty needs to be retained, no structured training and certification of surveyors, and geospatial is not a preferred vocation in universities. These are the challenges. This is I was part of this FICCI committee report on geospatial capacity building. It talks about broadly the skill pyramids, a skill pyramid for technical professionals and user organizations. So we need large number of manpowers for technical professionals, from programmer, developer, surveyors at lowest most level, then solution architect, domain expert, DBAs, and then program managers, project managers, and then at user organization side, enablers, process owners, and approvers. So more than 200 institutes are there and across the country. And this has to be, this is a part of one of the agenda of geospatial policy. This has to be addressed. And this FICCI report has also created a competency framework for national skill qualification framework for mapping, where job function, role, various NCQF level, core skills, domain, and tools, they are mapped. So this is my final slide. So emerging geospatial technologies and associated policy reforms for end-to-end geospatial ecosystem covering national geospatial policy, drone policy, space policy is a real good effort to accelerate digital transformation to make India world leader as per Vision 2047. Thank you.
Thank you so much, sir, for the insightful talk, especially throwing us light on leapfrog transformations in science of where, especially in India, its components, future scopes, and policy highlights. So now we'll open the floor for questions from audience. If you have a question, please unmute yourself and ask, or feel free to type it in chat box. You can unmute yourself and ask your question.
Hello, sir. Good afternoon. This is Harsha from OGC.
Yeah, Harsha, hello.
Thank you very much, sir, for a very what you call insightful presentation. All the work that has been done by the government of India under various programs to bring effective governance and the kind of solutions that have been developed. The kind of work that is going is really mind-boggling, I should say, because there is a lot of work on ground that is happening to bring transparency and efficiency into governance. I have a question from the because you're talking about the Geospatial Data Exchange, right? What do you think would be the success? Can you give me 3 pointers to make geospatial data more shareable by government agencies through platforms like the data exchange?
See, government, technology is not the issue. Say already before UGI initiative, open data platform of government is there. Okay. Harsha, you're getting me?
Yes, sir. I'm listening, sir. Thank you.
Oh, yeah. So data.gov.in is already there. And problem is not technology, even availability of platform, highly scalable platform, even the lot of force has been put as a part of National Data Shareability and Accessibility Policy 2012 by two various ministries and government department to share their data and APIs, including because of that initiative, every ministry through Cabinet Secretary and PMO, they have a chief data officers. But regular programs are done. But this kind of program is required lot of capacities and skills within ministries and human resource to build to share the data. Before sharing the data, making data ready for sharing in UGI, how they should build their APIs. Though backend pay, whatever NIC and ISRO and other agencies are doing, so they are doing it. But at ministry level, you don't have any capacity. There may be some joint secretary, some director has been designated as a chief data officer, but there is no resource and capacities available there. Regular training programs happens. Regular government orders for data.gov data are issued by cabinet secretary and everything that happens. But still, it is not getting what you call as a part of some kind of institutionalized mechanism in terms of human resource and also funding and data for development, scheme for data for development in every ministry. That is my cause. So some lot of effort to institutionalize that building data APIs, capacities, human resource to address this issue.
Thank you very much, sir, for the insight.
Maybe public-private partnership can also help in this direction.
Got it, sir. Got it. Thank you very much.
Hi, sir. This is Sandeep from CDP.
Okay.
Sir, actually, one important piece of information missing from the geospatial data we receive is the timestamp. So, do you think
Yeah.
this is important? And how can we mandate their inclusion?
See that it is important. It is important, quite important, and it should be available as a part of metadata. Should be available as a part of metadata.
Yeah.
And some of the information, particularly related to development schemes and the particularly non-spatial data where the real-time monitoring systems are being developed, they are being updated as per the frequency desired. Like for example, NREGA works. So whatever the works information that gets updated as a part of e-governance workflow systems. But update in geospatial information, say update of base map, that process has to be some kind of what you call at least Earth observation system with this real-time imagery like planet has built. We as a country, we need that kind of system where time series satellite data, time series map or automated feature extraction and building base maps and doing further analysis at top of it, all as a part of system to be built. And not only that, apart from time stamp, lot of work is needed in terms of quality and standardization.
Got it.
Have you got it?
Yeah, got it. Thank you. Thank you very much.
And also, let me tell you one thing. Some of the natural resource data like geology map or soil map, they don't change over time.
Yeah.
So such information will be there, but the development activity at top of it, like soil degradation happening due to some industry pollution, those pockets, those information should be updated part of e-governance system. So ultimately, soil map should become part of workflow of e-governance system, which is monitoring degradation of soil. You got the point?
Yeah, got it. Yeah.
So ultimately, you know which patches of land where soil alkalinity is increasing.
Yeah.
Which are the patches of land where soil erosion due to climate factor is happening. So if there is a system to monitor that, this soil map should get embedded as a part of workflow. Then uska regular update will happen.
That's correct, sir. Yeah. Thank you, sir. Thank you very much.
Any more questions from audience end? So this is Linda again. I have a question myself for you. So in the case studies, you have presented like mind-blowing applications where mapping rooftop solar panels using drone imagery, 3D visualization at village level. And the initial case studies you mentioned, like BharatMat Swamitva, I have even some key concerns, especially the quality and the consistency of data. Say a real-world entity mapped by different providers, there is like variance in the representation itself. So suppose I get a raw data from Swamitwa scheme and a raw data from mapped under NHP, National Hydrology Project. I see some raw data missing in Swamitwa is available in NHP and vice versa. So how do we address this type of data fragmentation?
See, the Swamitwa data contains only village abadi area. Okay.
Yes.
So Swamitwa data is basically not countrywide road network.
Okay.
It is only drone imaging of village residential area and where small streets are mapped. Okay. If you go up above, the major road data source is for rural areas, particularly is Pradhan Mantri Gram Sadak Yojana, PMGSY.
Yeah.
And over and above, what you call NHAI and Survey of India, of course. So what we have done from top in Bharat map, top down road up to say district, major district road, we have taken the Survey of India as a reference, and then further integrated with inputs from NHAI, and then down we have gone for Pradhan Mantri Gram Sadak Yojana. So that way we have followed the standardization. For bottom up, Swamitva data is only patches of Abadi area.
Okay. Okay, understood.
So that is what, so ultimately what we are trying to maintain from top down kind of thing, the accuracies with respect to Survey of India reference system, with updates from say NHAI and other agencies like that. And then internally, we are trying to take care of update using certain Earth observation satellite data.
Understood. So my last question. So there were many geospatial reports stating the forecasted numbers for, I mean, especially market design. For example, geospatial economy is projected to 80,000 crore by 2025 in one report. And there was this other report which states 63,000 crore by 2028 and so on. I mean, even the report states that these government initiatives, which you stated in the webinar session, contributed to it. So my question is, since I'm from GDI team, so I want to know, in your opinion, has this introduction of unified data exchange platform has influenced these numbers? And how do you think it will contribute in achieving above said markets?
See, I don't know how they can compute these figures. What is the model, data model at the back end they follow? Because, geospatial utilization and its market cannot be assessed in isolation with IT market or ICT market.
Understood.
No? See,
Yeah.
it cannot be done in isolation today. Maybe 10, 15 years back, when systems were not integrated that way, it would have been a different story. So similarly, UGI, how it is going to be impacting the market and other things. Definitely, it is going to be impacting in market. I will tell you one thing. Few days, I mean, last 1 month, few market research companies has contacted me, and they wanted advice. Say, if they have some of those companies has their own, this market research group is doing the assessment on behalf of some clients who are interested if they introduce geospatial database services for extreme weather in their software platform, how much investment and it will require and how much cost it is going to increase for their software platform. So this is what the assessment market research groups are doing. Similarly, digital marketing people contacted me how geospatial data and services is going to impact in terms of investment and their costing.
Okay.
If they embed those things in their platform, software platform. So that kind of awareness started coming. If UGI like platform is there and they need not to invest on data and geospatial knowledge infrastructure, they simply start consuming UGI platform APIs in their software platform as an external platform. I mentioned in my digital transformation component external platforms. One is internal digital platform of UGI, and then external platform which are going to be consuming APIs of UGI. So if you can monetization will also happen on UGI platform in due course. If these sectoral platform people can get certain cost benefit, definitely they will come and use UGI, and it will have a lot of market potential.
Understood. Understood, sir. So monetization is the route to contribute.
Monetization, and how it can give some kind, each sector player some kind of cost effectiveness. Can he do his business and enhance the value of his platform, his services, without investing on data infrastructure and data?
Okay. Okay.
You can have some kind of contract with such clients for two-way exchange of data, because by integrating their data, you can have another value-added service.
Understood. I got it, sir. Thank you, sir. So if there are no more questions, I'll conclude the session. So thank you once again, sir, for generously sharing your time, experience, and vision with us today. So your insights into evolving role of geospatial data in digital transformation have broadened our perspective. And to the attendees, thank you for joining us and being such an attentive, thoughtful audience. We hope the session sparks new idea and conversations long after it ends. So stay curious, stay connected. See you at the next data dialogue. Thank you all.
Thank you, Linda. Again, thank you, you and Center for Data for Public Good for inviting me. And I hope I am able to convey, because there are so many experts with whom I am interacting. So I hope I am able to convey whatever the thoughts I have.
You did, sir. Thank you.
Okay. Thank you. Thank you.